All right, hey guys, how you doing? My name is Alex. I'm down in Augusta, Georgia. Happy to be in class with you guys. Just want to give you about a 25-minute presentation on a project that I wanted to work on. Hopefully it'll be interesting to you guys. What you're looking at right now is Server 2016, the technical preview 4, so nice free Microsoft software to play with. And the first thing I'm doing out the gate is setting up, just giving it a rename. It gives a nice random string of characters that's really kind of a pain to work with. So that was one of the first orders of business. Just to give you guys some background, the ultimate goal of this project is really going to be to kind of set up a pseudo malware lab using, again, Hyper-V and Windows Server 2016. So we'll see how things go. If you have any questions, please feel free to chime in. I guess we can pause and take questions. But other than that, I'll try to give you tidbits along the way. But other than that, we're just going to go through a few steps of setting up the environment. So just so you know, I'm using an old laptop that I had laying around basically to be a domain controller. That's going to be a dedicated box. It shouldn't have any real issues. Not too much heavy lifting will be demanded. But the first thing we have to do after getting the initial install done is add a few of the roles. It's pretty simple. They make it pretty easy if you know what you want to do. The GUI is pretty helpful, as we'll see later. You pay a price for the GUI and performance, of course, but and size. But in this case, setting it up as a DC, it works out really well and gives some good learning points. So some of the things that we're adding, of course, we're going to add the Active Directory services. That's going to be huge to our domain controller. All right, hey guys, so we also have the remote server administrative tool, so that's also going to be helpful in helping us navigate through the network and get stuff done. We'll get a warning here in a second letting us know basically that there's an issue with us not having assigned a static IP address when we set up our DHCP server. That's not really a big deal. We'll get to that later. They just, of course, want to make sure that if you're going to have a fixture on the network that assigns IP addresses to everyone, that it's at least the same. So that's really just kind of Windows trying to help us out with trying to protect us from ourselves. So that's kind of a cool thing, and again, we'll get to that warning later. You'll see throughout this whole process that the process, we'll get a lot of warnings on different things. So it's nothing to be too afraid of. Now you see we have the Windows deployment services. That's also going to be huge. So I don't know if you guys have ever done any, if we have any sysadmins or former Windows guys, and then I apologize. This may bore you to tears, but I had a lot of fun figuring out the Windows deployment services are essentially what allows us to push the images out to bare metal systems, which is another project, another part of this project that I wanted to accomplish. All right, so now things get a little bit interesting. We go to install the Hyper-V role because hey, we want to manage them. We should probably have the role on our server, right? But then we get this nice little error, something about SLAT. For those of you who may not know, SLAT is the second level address translation, which is essentially just a hardware assisted virtualization. So I was a little bit concerned here when I realized I couldn't put this role on the laptop because it just doesn't have the, it's just not modern enough. It's a Core 2 Duo, so it does some stuff well, but it didn't give us that option. But that won't slow us down too much. So the good thing about this is we can queue up a bunch of things to install all at once. You'll notice I was a little bit timid in the beginning after changing the name. I thought about going to install some other stuff before the name changed, but I decided to go and let that get final before I press forward. So pretty content with that decision. Everything worked out well. So the next step here is going to be to, of course, promote the domain controller, which is funny because we don't have there are no other domain controllers to compete with. So that's just kind of the flag that it gives us and sends us to go do. So we oblige. We have to name it, again, keeping with the school spirit. We've got a computer information network system and then College of Digital Media. It should be a suitable enough domain name. We should all be able to remember it and relate to it. The next step is to set up the directory services restore mode password, which is essentially just a safe mode password to let us get in, and also verify that we want the global catalog and DNS server roles attached to it as well. Again, this is Windows kind of freaking out. Hey, there's no other DNS here. You're going to be the first, so it makes us go through some special warnings. But ultimately, it's we can accept the defaults here and then just click on through, and that works out well for us. The next thing you have is the log locations. Again, no real reason to change the defaults as much as possible. I think that helps keep things a little bit smoother. Speaking of smooth, we get to this screen that goes through a bunch of warning icons, but ultimately gives us that green check box saying that all prerequisites have been met, and then we can go through the install and the requisite requisite restart, which are rare, but you do have to have them to go through this initial round of installs, and it gives you the scary warnings just to make you think about things a little bit, and then we'll go through a little restart. All right, now my computer's not that fast. Neither is Server 2016. I'm doing some video editing to try to save you guys some time and pain, but this is my first crack at it. It's probably not going to be great, but ideally we'll save you guys some time and help get through some of this information. So first thing I wanted to check was, again, I said we'd get to it, was to set that static IP address. Just by the way, I don't have it shown here, but I did go ahead and disable DHCP on my router to kind of eliminate that as a potential conflict, and left it all up to this little 7-year-old laptop that I just had sitting around. So gave it a static IP, pretty much arbitrarily assigned that 121, but I remembered it for the whole lot of insane amount of hours that I played with this project, and then went ahead and made it its own primary DNS server, and then set up good old 8.8.8.8 as a backup, which will come in handy and pretty much keep us safe. I haven't had any issues going through this method, both on this DC or a previous iteration that was not nearly as polished. And say what you will about this one. So the next thing we have to set up is DHCP. DHCP, of course, is the Dynamic Host Configuration Protocol, which is what allows you to go from that layer 2 addressing to layer 3 addressing. It's pretty cool. So when I turned it off for the router and then checked the lease entries, I saw it pretty much taking it over for all the wireless devices as well in the house. They all just started coming to that little laptop that could to get all the information. So not just the network, but also not just the internal sends.cdm network that we're setting up, but also all the devices in the home. The one key to that though was after you have the role installed, then you have to go and set up the scope. So the scope is essentially just saying what you want the IP ranges to be when it's assigning IPs to different devices. So nothing too complicated. I'm sure you guys have run into this. Again, I apologize if it's boring. Hopefully it'll get more interesting as we go along, but part of the academic venture of this was to give as thorough of a solution as possible, so that if anybody's inclined to recreate this, they definitely can. Also, another cool thing about the project, Server 2016, the technical preview for is free, so we're not paying for any of this, and then we all have MSDNAA anyway, so that helped out with some of the host boxes that we'll use. But looking at the screen now, we did have to add in the exclusion, so we don't want it to accidentally assign its own IP address, even though it would be in the range of the scope that we set up. Clearly I could have changed that, but it gave me a reason to go through the exception policy and show that. Then we also have the lease timeout. So it's set to 8 days. It's kind of arbitrary. More times than not, when I notice it, they end up rolling over the same one anyway. But it is cool to just have that there's an option. We have wins. Again, we'll just leave that as the default, and overall reason to change that. And then we see our scope. We named it Nano Push because ultimately that's going to be the goal for it. But then again, since it's the only DHCP in the game on my network right now, it ends up taking over for everybody. So it's kind of narrowly scoped in name, but it does wonderful things. Now the next service we set up is the Windows deployment service. So this was absolutely cool. So if you guys have ever seen the network boot or ever played with that, again, if you're seeing it by accident, then you may be frustrated. If you're seeing it on purpose, then it's pretty cool because it means you've got a bare metal box that you are now pushing an OS to. So I did this after I'd already established it, so I'm just going through to show you guys the process of what it was like. The install images is where you put the Nano VHD X's when you are finished with them. And now we're skipping right to the install. You make them accessible there, then you make the boot image accessible, and now I'm showing you what it looks like from that bare metal box when it has nothing else to boot from. It goes to boot from the Pixie. It does its layer 2 advertisement, and you have to be really quick with the F12 there. If you're not really quick with it, you'll miss it, and you have to start all over. But as you can see, it's going to 121, which was our domain controller. It's pulling down the boot image, and then it's going to use one of the two already established Nano boxes that I already set up, and all that was done via PowerShell. I'm not huge on PowerShell. I got a lot bigger on it through this process because it's pretty much a necessity for the remote management and establishment of any of the Nano boxes. But just wanted to show, hey, they're both right there. You know, you can pick and choose. I went through one, what didn't have good luck, so then I put up another one that seemed to work a little bit better. And just so you guys know, I was doing all this on a 60 gig solid state that was in one of my desktops. Altogether, I think I used 3 systems and a handful of VMs, so it was a good time. Now we're just going through another reboot to let it go essentially through the normal process. All right, guys. So now we're back to our boot manager. So I lied. So there were other options for that system to boot from. I had some trial and error. So those 2 middle options, the 8.1 and the server preview, are no longer there. But I just hadn't cleaned up the boot manager yet. So now we're going to boot into 8.1. Pretty cool. So again, in case you don't know why this is significant, so Nano server is about 20 times smaller than the already reduced footprint of server core. It has no GUI. It runs less processes to be equally as effective, which basically means less attack surface. So you give it essentially the domain creds here. Notice I did not actually type the domain in because it's already been added. You can see it has the sends.cdm and the Nano name up top. Now you didn't see me add it to the domain. We'll get to the creation in the little PowerShell section at the end. The limited GUI that you do have, I realize I said there was no GUI, but there's a little bit. We'll just give you networking information, let you know what switch it's connected to, and also give you firewall options that you can enable or disable. So not too customizable. I'm not sure what the end state will be for it, but for now it just breaks everything down pretty simply. You either have it on or you have it off for common services. Thankfully, we can see that we have Hyper-V options there to indicate that we have the Hyper-V role installed and have that accessible. And also, as you can see here, there was already a switch installed, so that was done as a separate process. Again, we're going a little bit backwards, but now we're hopping over to our Windows 10 box, our workstation, primary workstation, and going through some VM action. So sorry for the quick transition, but I think you guys can keep up. It'll be good. It'll be good. So if you notice, I just ran Hyper-V, which is also free, by the way. Again, it comes with Windows 10. Which is a cool thing for folks about to graduate without access to the vast amount of DePaul resources. If you run it as the user, as a regular domain user, you might have noticed that there were no VMs that popped up, so that was kind of sucky. If I run it as administrator, which I should do anyway, given what we're doing, then it pops up some other test VMs that I've played with before. But we're going to go through a fresh install with the Windows 7 VM again, pulled off the MSDNAA site. Eventually, I guess I'll run into activation problems because I've thrown it like 3 different places across the network so far, but I think it gives you 3 days before activation, so I'm just going to ride out on that. It works out well. So right now I'm just going through the settings. This is all pretty standard stuff. If you've never seen it before, though, it's kind of cool to see it go through and set up the different components of your virtual system. One thing that also has to be done, that was done and then redone, was the addition of a switch. So unlike in VMware, if you guys are familiar with that, you have to set up the switch in Hyper-V for your devices to essentially be plugged in to be able to communicate. VMware handles it pretty much automatically. Hyper-V makes it a little bit more of a deliberate process, which isn't really a problem, but it works. So again, just going through picking the settings, making drive space that won't be too tricky. I have a decent amount of space, but I don't have a whole lot. So now it's just options of what you want to make and where you want to save it. Again, the effort now that we're doing is setting up our first host target box. It's based off, again, that Windows 7 image, Service Pack 1. We go to great concern not to trigger the automatic updates. It's only running on a 20 gig hard drive or a 20 gig virtual drive, which I later found to be troublesome. So I definitely learned my lesson there, and we'll give it a little bit more space in the future. But for now, we're going to go ahead and boot it up. I won't torture you guys too much through the install process, but again, this is fairly standard. But I want to try to make this as accessible as possible. So no surprises on the Windows 7 startup screen. Okay, we skipped a huge amount of action, threw in the activation code. Not that I don't trust you guys, but putting it on the internet, the interwebs. I don't want to have a harder time keeping my access. And you may have noticed that we just went to make sure we said no to automatic updates, because that will both blow up the system that's, again, on that small 20 gig hard drive or virtual drive, and also potentially patch vulnerabilities that we want to use the current website that's up, exploitdb.com, to have some fun with. So there's all kinds of different exploits. So the exploit shellcode, the web app exploits, remote exploits. I started pretty simple. The first one up there is remote exploits. I did some tinkering beforehand. Did a lot of tinkering beforehand actually to find one that would give us a good effective result. So many of them require a lot of setup to get the environment. I found this particular one, the Minolta FTP server, which serves decent enough purpose. It's just a regular FTP server, but apparently they left some vulnerabilities in it with regards to buffer overflow. So as you can see there, it essentially gives you the Python code for essentially logging into, and it's a hard coded, as you can see on the screen, hard coded IP address of that FTP server. Overflowing the buffer and pointing it to a different space in memory where you can then load your own command shell, which is what we were just looking at the hex for a short while ago. So this is the install of the vulnerable software. This is kind of tricky to do because sometimes if the browser is updated, then it gave you a hard time installing it. I tried to download it in Windows 10 just for funsies, and I couldn't even really get through that process because it already knew the software was risky and again was protecting me from myself. So here we already have it installed. We have it configured, the vulnerable FTP server, and now I really just I prefer to go to C drive just so we have more options and stuff to see as we're testing and make sure it's working. So that's all that setting change was doing, and of course letting it through the firewall so it can be effective. I mean, of course, with additional functionality comes additional attack surface, but that's okay because we need it in this case to have fun. So here we're just verifying the IP address. Another thing that I noticed going back to the Hyper-V install was after I got everything up and running and installed the switch, it blanked out the DNS information. So what you saw a second ago was me basically going back in to put that back in, set the switch back up to make sure I have functionality, and then connecting the VM to the newly established switch, of course with the vulnerable software already installed. So again, just verifying it's working. All right, and as you can see in the background, those are the contents of the C drive on this VirtualBox, and then I brought over a web browser from the host to make sure that it could connect to it too. And then we get to start with the fun stuff, which is setting up the attack box. So the attack box was actually done on a separate one of the separate partitions from the same box that's running the Nano server, except that we don't need it right now. So I was able to boot into if you remember the bootloader, the one that had Windows Vista, it turned out to be Windows 7, which was much preferred. And then we just set up really quickly VM player, nice and free. All right, so here we have a good bit of trial and error with that actual Python code that was pulled down. I tried, but to no avail to get it to work with our exploit. The most I could do was crash out the box. So there's a couple of times, again, just trial and error. If you'll see here, I'm going through. I fat fingered the IP address, the hard coded IP address, both of the listener. You can see the netcat listener running in the background, and also fat fingered the IP address of the FTP server. So the reason I knew I fat fingered it was because the results of it not working were the crash of the FTP server. It didn't do that, which let me know that I hadn't done anything. So I eventually got it working, and working in this case was essentially just a denial of service, as you can see there. Checking, verifying to see if it still works. It does not, but I also did not get a shell back to my netcat listener, and that made me sad. But then it encouraged me to find out another tool called the Enhanced Mitigation Experience Toolkit, which is pretty cool. Essentially what it allows you to do, and I'm searching for it here. I'll get an error because the browser's out of date, but that's okay. But what the Enhanced Mitigation Experience Toolkit allows you to do is disable security features that are inherent, that above and beyond a firewall or just app blocking. Processes that prevent different forms of stack exploits, essentially of memory exploits. So what I realized was, hey, the exploits are good, and they work some of the time, most of the time, whatever the case. But when you can tweak your environment a little bit to make it more vulnerable, then you give greater opportunities for training, greater opportunities for folks to learn stuff without the pesky security measures. So of actually identifying the the tool that the exploit in this case we want to use. There's a lot of them out there. So once we have it identified, then we set the remote host, which is the IP address of our target box. And then there's a little bit of flail on my part because I'm a little bit rusty with my Metasploit. But then we get the payload set to essentially return Windows shell. So the C prompt of our victim box, which is cool, which is helpful, and it's a good lightweight footprint, quasi non-intrusive thing to do, but not the ideal. And we'll get to the ideal in 1 second. So once we have that set up, we set the listening host. So essentially we put in the IP address of the system that we're on as a listening host. It'll automatically open the port up for us to listen on. Again, we could change to 4444 if we wanted to be stealthy. Then we would absolutely change the port as to not look extremely guilty. I feel compelled at times after we get the setup here to go back and just make sure that the service is still running, because of course if you're attacking a service, it needs to be functioning, or else you're not gonna have the best amount of luck. So in this particular case, we go through, no shell was created, so that makes us sad, but then we go to our tool. So we go check the apps in the Enhanced Mitigation Toolkit, and we essentially go through, and for the both for the server itself and the utility that configures it, which is probably not even needed, we disable all forms of the memory protection stack, buffer overflow protections that exist. Again, in Windows 7, the ones that aren't sexy enough to be advertised or in the news or well known, but they are out there. And if you're doing pen testing, then you know about those because they make your life a whole lot easier. But we turn those off. So now that we've got those off, we go through and we try it again. We hit exploit one more time. The settings are still there, and voila, we have essentially we have a shell on the target box. You'll see it's in program files, Konica Minolta. We don't have that in Kali. That's a pretty clear indicator that we made our way to the target box. So that's all well and good. The next question is, hey, so we're in this service. I wonder if we crashed it this time. So we go through and do some clicks. We click around. I could have been more focused to, again, only click on the ones we hadn't already clicked on, and I would have saved clicks again to verify what happened. But it's important that if you're going to go exploit onto a service or onto a program, that you know what the impact is to that program. In this particular case, we see that once we successfully exploit and get shell within this FTP server, we no longer have options to, it no longer works. So we don't have very long that we can hang out in that process after we've exploited into it to do whatever we want to do. So that's just lesson learned. The fix for that is, instead of sending the Windows shell code, which is what we set as our payload, we send the interpreter payload. So we don't get the C prompt, even though we can get to the C prompt from the interpreter shell. But the nifty thing that we can do from the interpreter shell is we can migrate processes. So again, I hope I'm not trying not to get too deep, but this is I think pretty standard stuff. If you're getting into a box, you get in through a process. You don't live in that process. You move to another process. In this particular case, I moved to actually the tool that was allowing us to change the security settings, which was process ID 3328, and I moved to it from process 1032, which was the Minolta FTP utility, because it's broken and soon going to be restarted. So now we're going to get into some of the background of everything that we're doing. This is going to be the PowerShell portion. It can be a little dry, but it was absolutely essential to everything that was, to everything running again with the server. So our goal here was to both set up an attack box, set up a victim box, and then deploy a victim box to the Nano server for operational use, essentially to have a test bed of systems that we could use. So what I'm showing you now, the code that's up top, is essentially the settings that we had to use, we had to type in to access the install image for the Nano server. It's not like a normal server where you just go through, click, the screen pops up, and you just click through for the install. In this particular case, that side file that I have up are the different packages that are included. So you have the compute package, which is the Hyper-V. You have IIS, so if you want to have IIS services, you can do that. What you're looking at now is PowerShell on the bottom, and then the scripting tool on the top. And essentially, this is the meat of how we got the server set up. If you guys have any questions about this, this went it was a lot slower when I was doing it than it is to actually explain. It's pretty self-explanatory though. You pick the target path, you run this from the folder on whatever system that you want to build it on, and there are two required files that you had to pull over again from that Nano server image, which is just a folder on the greater Windows Server 2016 image. So we go through, set the target path, we set the computer name, we use the OEM drivers. The dash OEM driver says that it's going to be a standalone. If it was going to be a VM, we would use the guest drivers. And then we add a few other packages in, particularly the container one, which will be fun one day down the road once they add additional support for that functionality. And of course we have, again, the compute container. This was done after the fact purely as a demo. I just wanted you guys to see it go through. I tried it from a box, from a system, the same system, but I tried it, logged into the domain. It did not work. I got back into the BD user, which is a domain user, ran the exact same command, and it worked like a charm. So that was pretty cool. The packages on the right again are the ones that they have now. My guess is they'll add more, but the key is precise functionality. So you don't have to add services that you don't need. So this will wrap up the demo creation of the Nano box, and now what you're going to see is basically the culminating, the thing to wrap everything all together essentially. So what's up on the screen now is we have a remote session set up with our domain controller. You'll see remote desktop to 121. And then I just want to go through and demo a little bit of what the visuals were, what the optics were. So I started with going through the process of getting into the Nano server. So all that has to be done through PowerShell. Trusts are a really big thing with PowerShell. So you have to add the IP address to the trusted host on your local box. And then of course you have to pass the admin credentials for the domain in order to get onto that box. So that, it makes sense. It does, but there's a pretty standard process there. You'll see it a million times as you're going through the Nano installs, because this is how you remotely administer via PowerShell. So this is something that you would just get used to. So I just set up the environment variable and then use the enter-ps session commandlet, put in the computer name, IP, and then the credentials. It asked me, and then it connected. So that's cool. So again, the additional commands that you see there, then I kind of start to play a little bit with the VM. So I had two VM images already built. So one was the WinV. That's actually not a 5. That's a V for Valentine. I stumbled across, let's call it a distribution of Windows that had been replaced with a lot of frilly heart, lovey-dovey things. My G3C consulting team will attest to the attractiveness of this particular distribution of Windows. But essentially, I took a pre-made VHD, created a new virtual machine on the Nano server, and then added that VHD, a virtual hard drive that contained the Windows 10 system, to that machine that was created. I also did another kind of replica of, there's the heart, there it is. I also did another replica of essentially the Windows 7 test box that we just exploited to get that to work. By the time it moved, I unfortunately did not make the update, did not hit the no to the automatic updates, so it lost pretty much all functionality once it was 19.5 gigs full of the 20 gigs I allotted it. So it was still there, it still moved over, but no real functionality. And then it here was just crashing altogether. But a quick restart, let me get back into it again. As a proof of concept, this was a really interesting project. So I was able to make VMs, and again in Hyper-V, made one exploitable, one was just a random one that I used for testing purposes. Transport that across the network to a bare metal system just via a Windows share, nothing extravagant there. And then using the roughly 500 or 600 megabyte Nano server, add the functionality that was needed to control those, and then from the domain controller or from one of the other domain systems, I was able to go through that system and administer it while running on that extremely small footprinted server. So here I'm just kind of going through again. This was the pseudo success moment in which I just went through and started playing with stuff. So just want to show you guys the DHCP leases. Clearly that's way more than just the systems that I set up. Not way more, but a few more. And again, that was just the normal household devices and traffic Here we see the Windows 7 box just came back up, so we logged in for fun. But again, what we just did here wasn't extremely hard, but a repeatable process of get an exploit, build a virtual target, build an attack box, set up a domain environment for it, and then do it on a really small footprint server. Pretty much all for fun and hopefully a good grade.